Okay, I welcome you all for the session. Here in this playlist, I would like to discuss the mathematics subject for the first year PUC science subject of Karnataka syllabus. The very first chapter I would like to discuss in this first video is partial fractions. Before going to define these partial fractions, we understand what is the fractions. Okay. So suppose an equation is given in two polynomials. Okay, suppose the equation is given in two polynomials. So this one will be called as a fraction. And before discussing the partial fractions, we must understand what is the LCM. Okay, LCM is that least common multiplication of denominators. Okay, we'll be taking for what LCM will be take for denominator terms will be take. I will give example here. 1 divided by x minus 1 divided by or take plus x minus 1. Here you take x plus 1. So what is the LCM of this equation? LCM. So LCM is x plus 1 and x minus 1, because these both terms are different individual terms. And if we take the LCM and multiplying that to the numerator, we will be get here x plus 1 is there, and here what is the remaining term? X minus 1. We will be having x minus 1 and plus, and here x minus 1 is there, and we will be taking the term of x plus 1 here. So x plus 1, and the LCM is x plus 1 into x minus 1, right? And the first term adding together, then x minus 1 plus x plus 1 means divided by here x into x square, and again this first term to the second term, here x will come, and the second term will be into the first term multiplication, x will come, and first to the second term minus 1, and here what is the equation will be get? Minus 1 and plus 1 get cancelled. Here 2x will be get, and if we resolving this denominator term, we will be getting that x square 2x minus 1. Okay, this is the one of the simpler form by doing the LCM, right? By taking the advantage of LCM, we are making the equation into one simpler fractions. What the partial fraction does, as we have been solved in a simpler fraction, so it splitting the partial fractions. It is splitting up of a given fraction into a number of simpler fractions. By the partial fraction concept, will be the given fractions will be resolving into a much more simpler than the LCM method. Okay, so that we will be understand after the discussion of when you are solving the problems. And we know the polynomial equation, right? So polynomial equation will be write as f of x is equal to a naught x to the power of n minus 1 plus a1 x to the power of n minus 2, so on. The last term is an. Okay, so here in this term a naught is not equal to 0. Here the first term will not be 0, and x is unknown here, and n is the degree of polynomial. Okay, n is the degree of polynomial. This is degree of polynomial. And if the equation the highest degree of the equations will be the degree of the polynomial. I will be give you an example. So x is equal to 2x square minus x plus 1. So what is the degree of polynomial is here? 2. because 2 is the highest degree here. And take another equation here, g of x is equal to x plus 1. What is the degree of polynomial here? Here highest degree of polynomial is 1. Okay, and here if we take the quotient of two polynomials means take f of x and g of x. The quotient means what? Ratio. So if we are taking the ratio of f of x to the g of x, and where g of x is not equal to 0, and it is called as a rational fractions. Okay, it will be called as a rational fraction, rational fractions or fraction. Okay, so why the term g of x is not equal to 0? Suppose if it is 0, then the rational fractions does not occur, means 1 by 0 term is what? Infinity. Okay, it does not have a sense. Okay, and then we'll be taking how we are generally writing partial fractions into a simpler fractions. Suppose you take an rational fractions in this term g of x, and take a one more term here h of x, and we are resolving this into a partial fractions as we are taking two constants, right? As we are taking a constant, and g of x we are writing with in separate, and h of x we are writing separate as taking the two constants. Like this we will be writing the partial fractions, and resolving the equations, and we will be determining the term. We will be finding the term a and b and putting the in the original equation. We will be getting the final equation, right? This is the partial equation. You just remember this is the in the form of partial fractions. Okay, in this rational fractions, types of rational fractions. What is the types of rational fractions? There are two types of rational fraction. One is a proper fraction and improper fraction. Improper fractions. So proper and improper fractions both will be defining with respect to of degree of the with respect WRT. Okay, I will write WRT with respect to degree of polynomial. Okay, with respect to of degree of polynomial, we will define the proper fractions and improper fractions. We know that here rational fraction is f of x to the g of x. This is the rational fractions we defined earlier, and this is the term is numerator term, and this is the denominator term, and the degree of numerator. So I just simply write as dn. Degree of denominator is less than the degree of numerator. Sorry, degree of numerator is less than the degree of denominator. Then we'll be calling as a proper functions. I will give a example here. Degree of 1 by x minus 1. Okay, here degree is no degree, 0 degree, and here we are having 1 degree of polynomial. So then it is denominator is less than the denominator, or either we can define as if the degree of the denominator is more than the numerator, it is a proper function. It is a proper fraction. And I will take the example x minus 1 x square plus 1. Which degree is more here? Denominator term is more. Then it is a proper fraction. Okay. Then improper fraction. So improper fractions, degree of numerator is greater or equal to the degree of denominator. I will show the example here. I will take x plus 2 divided by x minus 2. So here degrees are same, so then it is improper fraction. And x cube minus 1 x square plus 1, which degree is more? Numerator is more, then it is a improper fractions. Okay, it is a improper fractions. If the degree of numerator and denominator are same, then it is improper fractions, and the degree of the numerator is more than the denominator, it is improper fractions. If degree of denominator is more, then it is proper fraction. Okay, just remember these things, because these are very important. These two things These 2 points are very important to identify the given problem and solving the we can then we can able to solve the next problem. Okay, and there are three rules, and there are three rules for resolving the proper fractions into there are three rules for resolving the proper fractions into partial fractions. Okay, partial fractions. Okay, the first rule is that so it containing the equation or fraction containing a linear distinct term. Okay, distinct means what? Different term. Distinct term. Suppose I will give you example 2x minus 1 here, and here x plus 1 and x minus 2. So here the terms are both the terms are different, and like this of equations will be called linear distinct term. And if we are resolving these two into a partial fractions, so what will come? A divided by x plus 1 and plus of, we always take here plus. Okay, in between when we are resolving into a partial fractions, we always whatever terms or whatever the terms will be take, number of terms will be take, always will be plus. Okay, b divided by x minus 2. Suppose if c is there, then plus will be take plus. Okay, so this is a linear distinct term. And second one is repeated. If the repeated linear terms, repeated means what? Suppose this, I will take one more example, 2x minus 1 divided by x plus 1 whole square x minus 3. Okay, here x plus 1 is repeated. Okay, is repeating. So I will be write here this term into two times, x plus 1 divided by b divided by x plus 1 square. I will take here x plus 1 as a 2 times and with a degree of 1 and degree of 2. Okay, and x plus 1 plus x plus 1 square. If it is a cube, then I will write x plus 1 square and x plus 1 cube will be also come. And here I will write c is equal to x minus 3. Okay, I will take one more new page. And the third is non-repeating and non-factorizable. So means what? I will give you example here. X minus 1 divided by x, this is x minus 1, x square plus 1 divided by x minus 2. Okay, this is non-repeating and non-factorizable. Okay, so for like this equation here, it is not a single term as like x minus 2. So like this the term is given, then we have to write ax plus b, both together we have to write, and divided by x square plus 1 and plus c is equal to x minus 2. Okay, these 3 points you understood how to write. Okay, and suppose this is equation, right? I will write one more. Okay, these are the 3 rules. Okay, these are the 3 rules you must understand and know about this. And I will write a simple equation. You just identify and try to write. And here I will write here equation 2x plus 3 divided by x square minus 3x plus 2. How we can resolve these partial fractions? Don't try to resolve this equation as like this equation. Okay, because here term is x square plus 1. Okay, it is a single term. Okay, after it is a single term, x square after x is not there, right? After x is not there, and with a constant real number is there. After the x square, one real number is there. But this is in quadratic equations. Okay, you identified when quadratic equation is given. Here it is in quadratic equation, right? Quadratic equation, after x square, x term will come and then real number will come. This is quadratic equation. We need to solve this quadratic equation in a simpler form. Okay, suppose I am solving this equation x square minus 3x. You know about how to solve this quadratic equation. when we are solving this quadratic equation, we are multiplying this into this 2x square. We are having 2x square. Don't consider here sign, whether it is negative or positive. Don't consider, only multiply this into this 2 into x square, 2x square. If we are multiplying this equation, then we have to get this term, okay, minus 3. So 2 into 1 what? 2 into 1 2, minus into minus what? 2 into 1 what? 2x into 1x. I will take 2 into 2x into minus 1x, minus into minus plus, so it will be 2x square, okay, right? So these 3x I will write as, these 3x I will write in this form, x square, 3x I will write as 2x minus 1x plus 2, okay, plus 2 is equal to 0. This is equal to 0, you consider, and I will take here x as a common, and here x minus 2 comes, and here I will take minus 1 as common, then it will come as x minus 2 is equal to 0. So what is the common term here? X minus 2. Then I will write here x minus 1 here, and x minus 2 is common, x minus 2 is common, x minus 2 is common. This, like this we can write this, we can simplify this form into a 2x plus 3 quadratic equation into a we are solving the quadratic equation in a simple form, and it is coming as x minus 2, and this one we can write as a divided by x minus 1 plus b divided by x minus 2 in terms of a partial fractions. Okay, this one you must understand. Okay, what is the difference between this term and quadratic term? Okay, don't get confused. And now what we have to do if the rational fraction, okay, if the rational fraction is given in terms of a improper functions. What is the improper functions? Improper fractions is that when the degree of numerator is greater or equal to the degree of denominator. Okay, this is the condition for the improper fractions. I will just give an example for the improper fractions. X cube plus 2x square plus 3x minus 4 divided by x square plus x plus 3. Okay, this is in improper fractions. The degree of numerator is more, okay, than the denominator, then it is improper fraction, and in such cases we have to make into a proper function. Okay, we have to make it into a proper functions. How we can make it do? So by dividing first term by dividing this term to the this term. Okay, by dividing x cube plus 2x square plus 3x minus 4, I am dividing this by this term x square plus x plus 3. Okay, I will take here x, because here x square is there, I am multiplying this with the x, then it will become as x cube, and then x into x square and 3x. Okay, you know the rules how to cancelling the terms. Here plus term is there and minus, then here if minus there, then plus will come, and plus is there, here minus, if plus is there, here minus. So these two terms are get cancelled, and these two terms are get cancelled, plus minus get cancelled. Here 1 x square is remains, and here minus 4 is remains, and here x square term is there. Need not to take multiplication of x, we will be take the multiplication of 1, then I will be taking it as plus 1. Okay, plus 1, then here x square plus x plus 3. Okay, multiplying with 1 means here we have to take addition. Okay, then here minus get cancelled, and minus x term is not there above, here minus will come, and minus, so minus 3 minus 4 minus 7. Then we have to write this equation as in a simple form. How? X plus 1 we have to write, this term we have to write first, this term we have to write first, x plus 1. Okay, and then next we have to take we have to write a fraction of this divided by this divided by this. I will take minus common, then it will come as x plus 7 divided by x square plus x plus 3. Okay, this equation we can write in this form. Okay, this equation is equal to this form, and first term it is in polynomial form, we keep as it is, and we are solving this it is in proper fraction, right? The degree of denominator is more, and then we'll be solving this quadratic equation, and we will be resolving into a partial fractions, and then we'll be solving the equations. Okay, understood how to we have to resolve this improper fraction into proper fraction. Is a combination of, actually it is a combination of polynomial and proper fractions, and we are not solving the polynomial equations, and this equation we are solving. Okay, this equation in proper fractions will be resolving into a partial fractions, and then we'll be solving the problems. And now we'll be discussing the solving the problem based on the proper fractions. Okay, proper fractions. I will not tell just as it is proper function, and you just identify and we have to solve. Okay, I will give an example of here. Okay, in proper functions we have discussed the three different rules, right? 1, 2, 3. So based on first one rule I will solve one problem. Okay, first term is linear term. I will write just here 5x plus 6 divided by x plus 2, x plus 2, x minus 2. Okay, and here you just identify this is proper function or improper functions. Here I am giving the title proper functions, and in respective of that I am solving the problem. Just then you can tell easily as it is a proper function. But in examinations you have to identify this equation. Okay, you have to identify equation. If it is improper fractions, you have to make into a proper functions. But the given problem is proper fractions because x into x what? X square. So denominator term is having high degree than the numerator term, then it is proper fractions. And then we can write this equation in partial fractions like this. Here the equation not containing square and x square, okay, we can simply write as a divided by x plus 2 and plus b divided by x minus 2. Okay, we can write this. And what is the LCM term comes here? LCM term is x plus 2 into x minus 2. Okay, this what term is the here, that is the LCM. It is nothing but a LCM. Okay, x plus 2, x minus 2. Here multiplying this we are multiplying the x plus 2 and x minus 2 on both sides. Then what we have, suppose you take just right here a 5x plus 6 divided by x plus 2 and x minus 2, and this here x plus 2 is there, and we have to write here a into x minus 2, and here b x minus 2 is there, and we have to write x plus 2 here, x plus 2 and divided by x plus 2 and x minus 2. Okay, here both terms containing LCM term here same, it will be get cancelled. Okay, sometimes we don't have to require these two terms. We can directly write as like this. Okay, 5x plus 6 into x minus 2 and b into x plus 2. We can also write directly in this form because the LCM term will be get cancelled. And I will calling this equation as 1 and this equation as 2. Okay, this equation as 2, and here the values, if I put the values of x is equal to 2, then I will get the b term, and x is equal to minus 2, I will get the a terms. I just try to find the a term, then I will put here x is equal to minus 2. Okay, put x is equal to minus 2 in equation 2. Okay, so here 5 into x is what? Minus 2 plus 6, and here a is what? A into minus here minus 2 4. Okay, minus 4, and b term is minus 2 plus 2 is 0. Okay, plus 0, and here this is minus 10 plus 6 minus 4a. So here minus here I will write minus 4 is equal to minus 4a, minus 4 will get cancelled, and a is equal to 1. Okay, is it true? if I put the value of b side value, then I will get the a value. And okay, and now I will put x is equal to now I will put, so x is equal to 2. I will put, okay, this value I already have put. Now I will put this value, x is equal to 2 in equation what? In equation 2. Then it is 5 into 2 is 10 and plus 6, and a term is 0 and b term is 4b. okay, b term is 4b. Then it is 16 and 4b, 4 ones are 4 fours are, then b is 4. okay, b is 4. Put the value of a and b in the equation 1, and finally we have to write in the full form. okay, finally we have to write equation. We have to write the equation. I will take a new page here. okay, finally we have to write this equation. 5x plus 6 divided by x plus 2 and x minus 2. okay, a value is what? A value is 1 divided by x plus 2, b value is 4 divided by x minus 2. okay, this is the way to resolve the partial fractions. okay, this, and the now second problem will take based on the second condition is that repeated linear terms. okay, I will give an example here. 1 minus x divided by x plus 2 square and then x plus 1. okay, so here just try to identify which is whether it is a proper or improper. We can say easily, because in the proper function we are solving, but we always it is a good practice to identify proper or improper. X square, x here degree of polynomial is x cube, and here is x 1 degree. okay, 1 degree and 3 degree, so it is definitely proper function. Then we are resolving into this, just cancel this one and resolving. Then a divided by x plus 2 it is square, then repeats again term b divided by x plus 2 square, and then c term is x plus 1. okay, then resolving this equation 1 minus x. What is the LCM we are having? LCM is x plus 2 whole square, x plus 1. this is the LCM term, and here x plus 2 term is there and one more term remains, then x plus 2 and x plus 1. okay, a into and plus x plus 2 square is there, then x plus 1 is remains, and the c term x plus 1 is there, then x plus 2 whole square we have to write. okay, here the values x plus 2 and x plus 1 is there. Here x plus 1 is also there. We need to put this equation as 2 and call it as this equation as 1, and put x is equal to minus 2 here. This value I am putting x is equal to minus 2 in equation 2. Then we are having 1 minus of minus is plus 2, then a minus 2, a term is 0. okay, b term, b is minus b. okay, b into minus 1. okay, here we are having b into minus 1 and plus c is 0 term. okay, c is 0. Then we are having here b is equal to, so minus b is equal to 3, therefore b is equal to minus 3. And put x is equal to minus 1 in equation 2. What terms will be get? Put x is equal to minus 1 minus plus 1. okay, and then minus 1, then a term will be get 0, definitely a term will be 0 because and b term is also 0 and c term is c, okay, plus c, okay, therefore c is equal to 2. We are having c is equal to 2 value. And now what we have to which now to find the value of two value we got, okay, b and c. To find the another value we need to compare the x square terms. Here terms are over, x plus 2 and x plus 1. X plus 1 is repeats here, terms are over, then x plus 2 whole square is there. We cannot take we cannot put with the value of x, okay. Then what we have to do, here x square is there and here term is x into x square is there. We need to compare x square terms. We need to compare x square terms on both sides. If two unknowns, suppose if two unknowns are there, we need to compare x square and x, okay. But here only one unknown is there, so here only one unknown is there. Here only one unknown is there. That's why I am comparing this both terms with the x squares. So on the left side we don't have the x square terms, okay, in the equation 2, okay. We need to compare x square of the equation 2. Here I just write, we need to compare of x square term on both sides of equation 2. So equation 2 left side there is no x square and right side b term is there and c term a term is there and c term is there, okay. A term and there c term is there, and we need to find a. Therefore a is equal to minus c, so c value is 2, so it is minus 2. A is equal to minus 2, okay. Put the values of these in the final equation. What we have so 1 minus x, same repeating the equation number 1 with the putting the value of constant terms is x plus 1. So a value is minus 2 divided by x plus 2 plus b value is minus 3, okay, minus 3 x plus 2 whole square. Here we cannot write minus because always here in between we are writing a plus terms. Here b value is minus 3, okay, and plus 2 divided by x plus 1, okay. And then last the condition, the last rules we have discussed in proper fraction is that it is containing non-linear and non-factorizable terms. Non-linear and non-factorizable term. So based on that I will be solve one more problem. I will take the example of here the example of 2x minus 1. So x square plus 3 divided by x plus 1, okay. X square into x is x cube, a degree is more, it is proper function. And here it is a non-linear, right? X square is there, not a quadratic term is there. Then we can write here resolving into partial fraction how? According to condition 3, ax plus b, x square plus 3 plus c divided by x plus 1, okay. What is the LCM is here? LCM is this whole term x square plus 3. Then I will write here 2x minus 1 and here ax plus b into LCM is x plus 1 and plus c into x square plus 3. Is it right? Correct, okay. Then here the term x plus 1 is there, okay. The term x plus 1 is there, okay. The term we are having only one value to put here, so put this equation you call it as 2 and this equation you call it as 1. Put the equation x is equal to minus 1 in equation 2. 2 into minus 1 minus 2, minus 2 minus 3, and here minus 1, this term is 0. Okay, this term is 0, and minus here c is minus square is plus. Okay, 4c will come, and we will be having c is equal to minus 3 by 4. C is equal to minus 3 by 4 we got, and so only one value we got. Here another two values are unknown. Okay, means here a and b we are unknown. So are unknown here, a and b. So here a and b, how we have to identify? By comparing, just I informed before, comparing the x square terms. If two unknowns, then we need to comparing x square and x terms on both sides of the equation of 2. First we compare the x square. Left side is 0, and here right side is we are having with respect to of a, then a is there, and here is c is there, a plus c. Okay, a plus c, therefore we are having a, we need to identify a here, a is equal to minus c. So minus here, minus c is minus 3 by 4, minus into minus, plus 3 by 4. Then comparing the term x on both sides. So here in we are having term 2. Okay, and again we are having a plus b. Okay, a plus b, and then b we don't know. A value we know, right? 2. A value is 3 by 4 plus b. So therefore b is equal to 2 minus 3 by 4. So 4 LCM, then into 4. 8 minus 3 divided by 4. Here 8 minus 3 is 5 by 4. Okay, 5 by 4. All three values we got, a, b and c. Put the values of a, b, c in equation 2, in equation 1. Okay, then we can write the equation 1, 2x minus 1 divided by x square plus 3 into x plus 1. So we can write ax plus b. A is, so a value is 3 by 4 plus x plus b divided by x square plus 3 plus c is 3 by 4. Okay, plus c is, okay, c value what we have, c is in minus 3 by 4. Okay, c is minus 3 by 4. Okay, minus 3 by 4 divided by 4 into x. Okay, sorry, x plus 1. So otherwise also we can write here 3x plus 5, 4 return, here 4 will take to the downside, 4 into x square plus 3, and here we can write 3, 4 we are taking downside, then x plus 1 we can write as in this. We can also simplify like this. Now proper solving the proper fractions are done. Now we'll be discussing improper fractions. Okay, improper fractions. Okay, improper fractions. Okay, just I will give you an example. Minus 2x plus 4 x square plus 4x plus 3. Degrees are same, right? The highest degrees are same, and it is improper fractions. We need to solve this. We need to make into a combination of polynomial and proper functions. Then what we have to do? We have to divide x square minus 2x plus 4 by the this term, denominator term, x square plus 4x plus 3. Okay, here x square is there, x square there, then we have to multiply with respect of 1, then we will be writing x square plus 4x plus 3. So then here plus is there, minus minus and minus, this term will get cancelled, minus minus 6x, here plus 1 remains. Okay, we write here this, we can write this equation in the form of, here first term we will write 1 plus this divided by this divided by this divided, I will take minus common outside, and otherwise I can also write this 6 plus 1 divided by x square plus 4x plus 3. Okay, so now this term we can write as x square minus 2x plus 4 divided by, once again I am writing this equation, you can write like this. Okay, and consider the proper fraction, this second term, consider the proper fractions. Proper fraction, this is proper fraction, right, because degree is more than the numerator. Then here it is in quadratic equations. Okay, I already mentioned that it is in quadratic equation. We need to solve this equation. So 3 into x square is 3x square. When is solving this term, 4x has to come. 3 into 1, 3x into 1x is 4x square. 3x into 1x square is 3x square. And when we are adding this one, then we will be having 4x. When you are multiplying this, we will get 3x square. When we are adding this, we will be get 4x. Okay, then x square plus 3x plus 1x plus 3. So x, we are taking common x plus 3, and here taking common of 1, and x plus 3 is here, x plus 3 both side is there, and then will be common term is x plus 1, x plus 3. We can write this as in form of 1 plus 6 minus 6x plus 1 divided by x plus 1 and x plus 3. We are this term we are solving. Okay, I am writing this equation, that one minus 6. Okay, where is my cursor? Okay, so minus 6x plus 1 divided by x plus 1 divided by x plus 3. I am writing into a partial fraction as a divided by x plus 1 and plus b divided by x plus 3, x plus 3, x plus 3, and LCM x plus 1 into x plus 3 LCM, then 6x plus 1 is equal to a into x plus 3, and same repeating the steps, x plus 1, and then put the value of this equation is 1 and this equation is 2, and put the value of x is equal to minus 1, then we will be get the value of a, then minus 1 7, here 7 will come, and a into minus 1 2a will come. So therefore a is equal to 7 by 2, and put the value of x is equal to minus 1 in equation 2, then put the value of x is equal to minus 3, x is equal to minus 3, 18 plus 1 19, and a term will be 0, and b term will be b into minus 2, and this is 19 and minus 2b, so b is equal to minus 19 by 2. Okay, minus 19 by 2, and we can write this final form of equation as like this. So final form of the equation, we can write x square minus 2x plus 4 divided by x square plus 4x plus 3 is 1 plus, okay, 1 plus a value is 7 by 2 of I am taking the two denominator term downside as x plus 1 and minus of 19 by 2 x plus 3. Okay, this is the final form of partial fraction equation. Okay, and also you try to solve this other more it is my suggestion to solve more improper the problem based on improper functions. And one more questions I will be solving, which is many times has been asked in your CET examination. So the equation is that if condition they have been given, if 1 divided by 1 minus ax into 1 minus bx is equal to 1a divided by 1 minus ax plus b divided by 1 minus bx. They are resolving, they have been resolved here. Then we need to find, then we need to find 1 divided by a 1 minus ax square and 1 minus bx. We need to find 1 minus ax square and 1 minus, these two terms seems to be same, but the thing is the square is there. We need to identify these terms. Okay, then writing the same term again, because we need to find this equation 1 minus x square to 1 minus bx. We can able here taking the common of 1 minus ax. I am taking the common of 1 minus ax. If I take the common of 1 minus ax, here inside one term will be there, 1 minus bx into 1 minus bx. Is it right? I can write like this into I can write this in a simple manner, right? I am taking common out. Why? Because the inside term is containing this term. Okay, so then now I can write 1 minus ax, and this inside term I can write as a plus a divided by 1 minus ax and plus b 1 divided by bx. I can write? Yes, of course I can write. And then what I do, I will multiply this 1 minus ax into inside. Then it will be get 1 minus of ax square and b into 1 minus ax into 1 minus bx. Is it right? I am multiplying this into inside the term. Then again a divided by 1 minus ax square will be there, and I will take a common of b. So if take we common b outside, then it is 1 divided by 1 minus ax 1 minus bx. Again it is the same as the term again, 1 minus ax 1 minus, and if I take the b is outside, then 1 divided by 1 minus ax 1 minus bx, which is given plus 1 divided by 1 minus bx. So now we can write as a divided by 1 minus ax whole square plus ab. We are multiplying this a into b, ab divided by 1 minus x, and b into b is b squared divided by 1 minus bx. This is the final form of equation. Okay, this is the final form of equation. Okay, one more problem I will be given just here. You may probably get confused. So here in the given problem, x cube plus 16 x minus 2 to the power of 4. Then it is proper or improper? It is proper because denominator term is more. Here if we x tends to 4 is given, but it is more term, we can also possible to write a is x minus 2 and b divided by x minus 2 whole square, and you may be thought of this to writing this like this, x minus 2 is equal to minus cube and d divided by x minus 2 raised to 4, but it is very difficult to find all those values. So what we do, if a ratio of 4 is given, it is better to consider a value. It is better to consider a value. Okay, if fourth term is given, then what you have to do, better to assume x minus 2 as a y. Assume x minus 2 as a y. X minus 2 as a y, and then x is what? And x is y plus 2. X is y plus 2. Then we can write x cube is what? Y plus 2 whole cube. Y plus 2 whole cube plus 16, and x minus 2 is what? Y raised to 4. and okay, and this a plus b whole cube formula is what? A cube plus b cube. B cube is 2 cube is what? 8. A cube plus b cube plus 3ab, 6y will come here. 3ab means 6y come here. 3 into a into y. Okay, 6y. 3ab into a plus b. So a plus b is what? Y plus 2. This is the equation for a plus b whole cube. What is the formula for a plus b whole cube? Is a cube plus b cube plus 3ab, 3 into ab into the bracket a plus b. The same thing I am writing here. And the next is plus 16 and then y raised to 4. Okay, y raised to 4, and again I am simplifying this here term, y cube and plus here 6y into y, 6y square, and here 6 into 2, 12y will come, 12y come, and 8, 16 plus here 16 plus 8, 16 plus 8, 24 divided by y raised to 4, y raised to 4. And now you divide this term by y raised to 4. Dividing y raised to cube divided by y raised to 4, what? 1 by y remains, and 6 by y square, 6 by y square remains, and 12 divided by y cube remains, and here 24 divided by y raised to 4 remains, right? And the y raised to 4 I am dividing on each term, then I will be getting this term. And now you put the value of y. The right side term is x cube plus 16, x cube plus 16, x minus 2 plus 4. Put the value of y. Y is what? So y is x minus 2. So y is x minus 2. Right. This equation is as we have predicted previously. The equation will become as a to the divided by x minus 2, x minus whole square, and x cube, and x minus 2 whole raised to 4. This is in the same form, right? This is in the same form. Okay, this is in same, but the values are we have been identify easily. When by assuming like this. Okay, when the higher degree is given, we have to assume x minus 2 as a y, and the formula, and here a plus b whole cube formula will come, and solving that formula and dividing each term by the y by 4, then equation come, and again y term we have been put value of y, then what we got the value of this. Okay, this problem is very important. Just you have to remember that when the high degree is given, okay, fourth term, when cube is given, you try to solve like this. Okay, when high term is given, then it is my suggestion to assume a value. Okay, this is the overall discussion of partial fractions. I request you to subscribe my channel and share to your friends. Please watch for more videos and your concept for this channel. Thank you very much.